All right, a complete bipartite graph is a graph that goes from two different sets of vertices. So k sub 2, 3 means you're going to have two vertices here on the left-hand side. So this is one set. And then the other set of vertices, you're going to have three vertices on this set. So for every pair, right? So this is just a long way of saying there's a pair of, there's a set of vertices here, and there's a set of vertices here. So two on the left side, two on the right side. Okay, so these vertices here are not going to be connected to each other. These vertices here are not going to be connected to each other, but every vertex here on this side has to be connected to every vertex here on this side. So this vertex here has to go to each of the three vertices, and this vertex here has to go to each of the three vertices. This is a bipartite graph. So that's a long way of saying this, right? Okay, so here we go. So k sub 3, 3. So this 3 here means I have three vertices on the left-hand side. This 3 here says I have three vertices on the right-hand side. So remember, these vertices are not connected to each other, and these are not connected to each other, but this vertex here gets connected with every vertex on the right-hand side. This vertex here gets connected with every vertex, and then this vertex here gets connected with every vertex on the right. And I'm going to let you do that one for Zoom. All right, let me make a note of that. Okay, so now we're going to talk about subgraphs. So a subgraph of a graph G. So let me just draw a G. So here's a V1, a couple of edges. There's a V2. There's a V3, a V4, and then a V5. And then I'm going to put a loop there on V5. Okay, so a subgraph H of a graph G. So this is my graph G. So every vertex in H in the subgraph is also in G. And every edge in the subgraph is in G, and every edge in H, every edge in H, the subgraph, has the same endpoints as that in G. So you're not adding, your subgraph is not adding to it. So one subgraph, H, could be this. So this vertex is in here, and there's not additional vertices, right? But this is part of the graph of G. So this is the graph of G, right? This is the graph G. And so now this is one subgraph. So let's do another subgraph H. That's what they're talking about. H is a subgraph. So H could be a subgraph if I picked up that, right? I could have another H that's a subgraph. I think you get the idea, right? So this here is part of this graph. So every subgraph has to be, should be able to just pick it up and put it into my G, and it works. So what is not, let me just make a devil's advocate, V2. And then if I went here to V5. All right. So here's my V1 to V2, right? That's part of this here is part of the original graph. Check. Wait a minute. Is there supposed to be an edge between V2 and V5? There is not. So this is not a subgraph. All right. So I think you get the idea. Okay. So now we need to talk about the degree of a vertex. So let me get a picture going here. So here's your V4 and a V3, a V1. Just gonna stick a loop on there just because I can. Stick a loop on there and connect those two. And then I'm gonna have V5 out here by itself. Okay, whoops, the loop's supposed to come connect. All right, so let's talk about the degree. So V5 has degree, let's see, the degree of a vertex is the number of edges incident on the vertex. There's no edges, so it has degree 0, right? All right, let's look at vertex 4. This has degree 1, because there's one edge incident that comes into that vertex, right? Okay, so let's look at vertex 3. So vertex 3 has this edge coming in, this edge coming in, and this edge coming in. So this vertex has degree 3. All right, so now let's look at our V1 and our V2. Okay, I'm going to pick up a different color here. So let's look at V1. So I've got this edge, this edge, this edge, and this edge. So there's 4 edges. So this loop gives 2 degrees to this vertex. So same with this, right? 1, 2, 3, 4. So these both, right? These both have degree 4. All right, let's stop there.